Okay, so this is a practice statistics test that was for MYP3, but the video's also here for the benefit of MYP5 to revise nearly everything in statistics. So it says here is some data about the heights, and that should say of two groups of people. Now actually there were two tables, one for each group of people. I've only put the one here for now just to show generally how it's done. So this is one of two tables about data about people's heights. So this is, let's say, group 1. Estimate the mean of each group. I've kind of mixed up two tables together here because I've got a grouped frequency table for estimating the mean, but I've also got a cumulative frequency column which is for something else that I'm going to do later. So I'll start by forgetting the cumulative frequency column and just concentrate on trying to estimate the mean of this group. So we've got various people in each group, 2, 4, 6, 5, 2, 1, so they add up to 20. So there's 20 people in the whole thing. And in the first group there's 2 people. They're between 150 and 160 centimeters tall. Now we've got no information about where they are within that group, so our best estimate is to say that they are both 155. Just say that everyone on average is give or take about in the middle. Same for the next group. The middle of 160 and 170 is 165, and then just straight down all the groups, putting everyone in the middle of each group. The last group is actually from 200 to 220, so it's a wider group than all the others, and the middle of that is 210. So we're saying all the people in the groups are in the middle of the group. Now looking at the first group, we've got 2 people. We're saying that we're estimating that they're 155 centimeters tall each, so that makes a total height of 310 for those people. 2 times 155. Same for the next group, 4 people, 165 centimeters each, so that makes a total height, if you stacked all of them on top of each other, 4 times 165, 660. So I'm going like that for all the groups, working out the total of all the heights, and then I'm going to tot all of those up to get a grand total of all the heights. If you stacked everybody on top of each other, there would be a total height of 3,545 centimeters. So that's the total height of 20 people. So the mean height is the total height divided by the total number of people. So there it is, 3,545 is the total height of 20 people, so the average is 3,545 divided by 20, which is 177.25 centimeters. And just looking back at the original data, that kind of looks like a reasonable answer, bearing in mind the original numbers we had. So question 2, what is the modal category of each group? Well, you've heard of the mode, so the modal category is just like the mode. It's the one that there's most of. So the group with most in it is the group that's got 6 in it. There's more in that group than in any other group, but that doesn't mean that 6 is the mode. The modal category is the group that's got most people in it. So the modal category is 170 to 180. What is the median category of each group? Well, let's just remind ourselves about medians. There's 20 people, so the median person is the middle one if you put them all in order. There's a little formula for that, n plus 1 over 2. So 20 people plus 1 divided by 2 is 10.5. So the person in the middle is person number 10.5. So between person number 10 and person number 11. If you think about that, if there's 20 people and you're between person number 10 and person number 11, then you've got exactly 10 people one side of you and exactly 10 people the other side of you. So 10.5 is the midpoint of 20 people, but that doesn't mean that 10.5 is the median. The median is the height of the 10.5th person. So let's just think about which people are in each group. So the first group has got 2 people in it, so that's person number 1 to person number 2. Because that group ends with person number 2, the next group has to start with person number 3. And then it's got 4 people in it, so 2 plus 4 means that it ends with person number 6. Now that might look like 3 people to you, from 3 to 6, but if you count them out, 3, 4, 5, 6, that's 4 people. So don't get confused by the fact that 6 minus 3 is only 3 and not 4, because you're counting the people at either end as well. So 3, 4, 5 and 6 is clearly 4 people. And just remember, if you take the end of each group and then add the number of people, that should give you the end of the next group. So the next group, because the last group ended with 6, the next group has got to end with person number 7. And then the last group ended with person number 6, add on another 6 people means the next group has got to end with person number 12. So that means that the next group has person number 7 to person number 12. Now you might think 12 minus 7, that's only 5, but again, if you count them out, 7, 8, 9, 10, 11, 12, that's 6 people because you're counting the people at both ends. Okay, next category starts with person number 13 and another 5 people, 12 plus another 5 makes 17, and because that's 17, the next category's got to start with person number 18 and then an extra 2 people, so previous 17 plus an extra 2 people makes 19, and then the next category has got to start with person number 20, and then 19 plus the extra 1 person makes 20, so the last group is just person number 20 to person number 20. It's person number 20 on his or her own, just 1 person. So the whole thing finishes off with person number 20, which ties in with the fact that we've got 20 people. So out of all those people, we're looking for the middle person, person number 10.5. And you can see from what we've done here that person number 10.5 would be in this group. So the median category is the category that the middle person is in. So in this case, 170 to 180. Question number 4, make a cumulative frequency graph for each group and estimate the median and the quartiles. Okay, so this time I have put both groups in, and I am going to do this for both groups. And we're looking at cumulative frequency, so we're not bothering about the other columns that we used for the other bit of the question. And the cumulative frequency is the total so far. So looking at this one, we've got 2 people at the start, so that's, oh, and they add up to 20, of course. Yeah, so 2 people at the start makes 2 so far. Then we've got an extra 4, so that makes 6. Then we've got an extra 6, so that makes 12. An extra 5 makes 17. An extra 2 makes 19. And an extra 1 makes 20. So again, that comes to 20 at the end, which is no surprise because we know that there are 20 people in it. And then the next group, so again that's also 20 different people. 3 people at the start makes 3 so far, an extra 6 makes 9, an extra 5 makes 14, an extra 4 makes 18, an extra 2 makes 20, and then the last group with 0 in means we're still at 20. So the cumulative frequency always goes up because you're adding something to the running total all the time. Now, the points that we plot on the cumulative frequency graph are as follows. First of all, we're going to plot 160 against 2 to show the fact that there are 2 people whose height is something up to 160. Then we're going to plot 170 against 6 to show that there are 6 people whose height is something up to 170. And then we're going to keep doing that. It's basically the end of each category against how many people so far to show that there are this number of people whose height is up to a certain amount. And then last of all, we're just going to plot the start of the first category against 0, and that's telling us that there are no people whose height is under 150. Okay, so the same thing for the other table now. So 160 against 3, showing us that there are 3 people whose height is something up to 160. You might want to pause the video now and try this yourself. 179, 180, 14, 190, 18, 220, 220, 20, and then finally 150, 0 in this case, showing us that also in this group nobody is under 150 centimeters. So on the graph, here's the first group. We're plotting all of those points. There they are. So it's the heights along the horizontal axis and the cumulative frequency up the vertical axis. So you get this sort of elongated S shape, which is often how it comes out to be. And trying to join those with as smooth a curve as you can, going through all the points. And then yes, and then the next bit of the question was to estimate the median and the quartiles. So remember, the median is the middle person, which is person number 10.5, as we discussed. So we can read that off the graph and say, there's person number 10.5. So if we read across until we hit the line and then read down, so that person is approximately 178 centimeters. So we can use the cumulative frequency curve to estimate the median. The middle person has a height of 178 centimeters. Now the quartiles, so just like the median is the middle person, the quartiles are the people who are at 25 and 75%. So 5, because 5 is a quarter of 20, the 5th person is a quarter of the way along, and their height is approximately 169 from the graph. And then the upper quartile, so 3/4 of 20 is 15. So the 15th person, we can estimate their height to be around 185. So the quartiles are actually 3 values. You've got the lower quartile, Q1, 169. The upper quartile, Q3, 185. But actually the median is also the middle quartile, but usually we just call it the median. But the quartiles are 3 values that split the data into 4 25% chunks. And here's the other group, and then in this case, when I plotted all the points and estimated the median and the quartiles, I got some slightly different values than for the other group. Question 5. Represent the 2 groups on a box and whisker diagram and comment on the differences. So a box and whisker diagram is a classic way of comparing 2 different groups of people over a similar property. So in this case, their heights. So I've got the heights along here on the horizontal axis. I should really have labeled that axis height in centimeters, so slap wrist for me. So this is group 1 showing the full range of the data. So in group 1, the lowest value was 150, the highest value was 220. the median was, well, we've just seen it there, the median was 178, so that's just corresponding to 178. And then the lower and upper quartiles were 169 and 185, so that's just my 169 at the bottom of the box and my 185 at the top of the box. So a box and whisker plot is showing lowest, highest values, and then the quartiles in the box, the lower quartile at the bottom of the box, the upper quartile at the top of the box, and then the median as a line in the middle of the box. So I've done one of those for group 1 and then also for group 2. And in a classic box and whisker plot exam question, you're looking to make 2 comments and support them with data. You're looking to make a comment about the central location of the data. So group 1 is slightly taller than group 2, and you can see that by comparing the medians. There's the median for group 1, 178, whereas group 2, the median is only 173. And then the other thing you're looking to compare is the spread of the data. So you can do that by either looking at the range. So there's a much greater range of values for group 1 than for group 2. But actually a slightly better measure is the interquartile range. And that's slightly greater for group 2 in this case. And the interquartile range is a slightly better measure because just the range really depends very much on the biggest and smallest values, whereas the quartiles, they're much more affected by all of the values around them. So I personally prefer the interquartile range as a measure of how spread out the set of data is, and in this case there's not too much difference between the interquartile ranges, slightly bigger for group 2, but in any case, in an exam question, that's what you're looking to do. Where is the central location of the data? So compare the medians. Median for this group is bigger or smaller than the median for that group. And then second thing in an exam question, compare the range. So, or compare the spread, and often by comparing the interquartile ranges. Okay, the next bit of the practice test had some math scores for 20 people. So this isn't a grouped frequency table, it's just some straightforward test scores for 20 people listed, and also the hours that they spent revising, because we're going to look at correlation in a minute. So this is kind of easier than when we worked out the mean in a grouped frequency table before, because this is just good old add them all up, divide by how many there are, 20. So it's just add up all these numbers, divide by 20, and it came to 67.9. What is the median score? Well, the median is the middle when you've got all the scores in order. So again, it's the 10.5th value out of 20. So if we stick them all in order, which I've done here, then the median is between the 10th value and the 11th value, and that's just between 65 and 69, so we take it as the mean average of 65 and 69, which is 67. What is the modal score? The modal score, or the mode, is the one that there's most of. Now in this case there's two 89s and there's two 100s. So this is an odd case where it's bimodal. There's two modes. And which of the above three types of average best represents the data? Well, the fact that the modes were 89 and 100 doesn't really say much about the data set as a whole. Whereas the median being 67, that kind of is in the middle, and then the mean being 67.9, they're quite close to each other, and those two tell us a lot more about the data set in general than the mode does. So in this case, the mode is not very good, but the mean and the median are much better. Question 10. Represent the data on a scatter diagram. What do you observe? So each of these lines, to be clear, is a particular person. So there's 20 lines for 20 people with the number of hours they spent revising and the score they got in a test. So plotting these as pairs of values. So hours revising horizontally, score vertically. And I've deliberately done it that way around because conventionally, if one variable is dependent on the other, then you generally put the dependent variable on the y-axis. So the score kind of depends on how much they studied, or it should do, not the other way around. So plotting those points, we get that, and it seems that the more hours you revise, the higher the score you get. They are positively correlated. So what we observe is positive correlation. There are two other possibilities we might observe. We might observe negative correlation, where one thing going up makes the other go down, or it might be completely random, which would be no correlation. Now the next bit is calculating the rank correlation coefficient. This is absolutely not on the MYP5 exam, so if you're MYP5, don't worry about this for the moment. But what we've done is we've ranked the number of hours spent revising. So the people who spent 9 hours are first equal, and then because they're both first equal, they occupy first and second place. So we've designated them both as being 1.5, the average of place 1 and place 2. Then the next three people are third equal, so they're occupying place 3, 4 and 5. So the average of those is 4, so we've designated all of them as fourth place. The next one's sixth place on its own, and then I've kind of done that for the whole thing, ranked the hours that they spent revising from 1 down to 20. And I've done the same thing with the score, so there's that. And then I've got this column D, which is the difference between those two ranks. So person who spent the least hours revising got the least score. So the difference between those is 20 minus 20, which is 0. And I've done that for all of those. And I've squared the differences, which is that. So 0 times 0 is 0. Minus 1.5 times minus 1.5 is 2.25, and so on. And then I've added up the sums of those squares to get 90.5. Then I've bunged everything into this formula. So the sigma d squared means the sum of all the d squareds, which is the 90.5. So the correlation coefficient is 1 minus 6 times the sum of the squares, 6 times 90.5, divided by n brackets n squared minus 1. N is the number of people in the whole thing, so that's 20 times 20 squared minus 1. And that whole thing comes to 0.932. Now the idea is with a correlation coefficient that if you get a value of 1, then it's perfectly positively correlated. If you get a value of minus 1, then it's perfectly negatively correlated. And if you get a value of around 0, then it's not really correlated at all. There's no correlation. So the value should always come out to be between 1 and minus 1, and in this case 0.932 is very close to 1, so that indicates strong positive correlation. And indeed, if we have another look at our scatter graph, that concurs with that they are very strongly positively correlated. And just to reiterate, the calculation of the correlation coefficient is definitely not on the MYP5 exam. So draw a line of best fit and use it to predict a score of someone who worked for 3 hours. There's a line of best fit. Now it should strictly go through the mean average point. So the average of all the hours and the average of all the scores I worked out to be a point around there. So just adding up all these and dividing by 20, adding up all these and divided by 20. So that's the mean average point. So a line of best fit should go through that point, and then, well, at MYP5 or MYP3 level, all you're really doing is just trying to pivot a good line around that point that seems to be a good fit for the data. When you go into a higher level, there are more sophisticated methods of placing that straight line in the most optimal place, but you don't need to worry about that yet. So there's my line of best fit, and it'll be slightly different for different people, but it should, strictly speaking, go through the average point. And predict the score of someone who worked for 3 hours. So there's 3 hours, and if I read up from 3 hours to the line, I can predict that that person might be expected to get a score of around 45 in the test. Now, it doesn't guarantee that, it's just an estimate of what they might expect to achieve, but of course there is random variation of the real data around that line. So prediction: someone revising for 3 hours could expect to score 45%, but it's by no means guaranteed. Okay, the very last bit is about histograms. So I've got the weights of 2 people, and the point with a histogram, it looks like a bar chart, but instead of the heights of the bars representing the frequencies, it's going to be the areas of the bars that represent the frequencies. So this is particularly important when you've got different widths of bars, because the category widths are all different. So the first category here is people who weigh between 45 and 50 kilos. There's 5 of those, and the class width is 5, because from 45 to 50, 50 minus 45 is a range of 5 kilos. The next category, from 50 to 60, that's a range of 10 kilos. And then the next group, 60 to 70, the class width is 10 kilos. Next group, 70 to 80, that's 10 kilos. Next group, 80 to 100, that's 20 kilos. And the next group, 100 to 120, that's 20 kilos. So the point is, we want to do a graph where the area of each bar corresponds to these frequencies. So the first one, for example, if we want a rectangle to have an area of 5, and we know that it's going to have a width of 5, then the height of that rectangle has to be 5 divided by 5, which is 1. That's supposed to be a division symbol. It might look a little bit like a plus if your screen is particularly small, but it's a division. Next group, we want a rectangle. We want the bar to have an area of 8 units. It's going to have a width of 10 units, so the height of the bar is going to be 8 divided by 10, which is 0.8. Next one, 10 divided by 10 is 1. Next one, 8 divided by 10 is 0.8. Next one, 6 divided by 20 is 0.3. And next one, 3 divided by 20 is 0.15. So we're going to make our histogram now. So it's going to have the heights along the bottom and the frequency density. So these things that we just calculated, the heights of the bars, are called not the frequency, because the height isn't going to represent the frequency. They're called the frequency density. So here's the first one. It's a bar with a width of 5 centimeters. Now that's a mistake, isn't it? That's not supposed to be height. It's supposed to be weight, isn't it? So that's my mistake, but you can hopefully overlook that. But Yeah, so it's supposed to represent a weight of 45 to 50 kilograms. I certainly don't know many people who are only 50 centimeters tall. And the height of the bar is 1 unit, but the area of the bar is 5. So it's that area of 5 that represents the frequency. So the next one, it's a wider bar because it's a wider category. The height of the bar is 0.8 on the scale of frequency density here. And the area of the bar is 8 units. So even though the red bar looks lower than the blue bar, it's representing more people. The red bar is 8 people. The blue bar is only 5 people. So although the blue bar is higher, the area of the red bar is bigger, and it's that red area that's representing the 8 people, not the height. So the red bar is smaller in height, but it has a bigger area, and that area is the important thing that corresponds to the number of people. Okay, next group is a class width of 10 from 60 to 70, and the height of the bar is 1, as we worked out here. And then the next group is going to be from 70 to 80, and the height of the bar is going to be 0.8. Next group from 80 to 100, so that's going to be a wider bar. It's going to be 20 units wide from 80 to 100. And the area of that bar is 6 with a height of 0.3. And then the last one, it's going to have a frequency density of 0.15. So the height of the bar is going to be 0.15. The width of the bar is going to be 20. And that makes the area of the bar equal to 20 times 0.15, 3. So just remember that a histogram, the important property of that is that the area, and not the height of the bars, represents the number of people. And therefore the height of the bars isn't the frequency, but it's this thing that we calculate called the frequency density.